Hi friends, in this video we learn about signal to quantization noise ratio for linear quantization in PCM, right? So let us start with this. Okay, what we know about is SNR. We know the signal to noise ratio is given by normalized signal power divided by normalized noise power. This is what SNR we know, normalized noise power. Fine? Okay. So, and we know for PCM, normalized noise power, we know that it is del squared by 12. Okay, so SNR is equal to normalized signal power by del squared by 2. So I have to find out what is this normalized signal power and everything. Okay, let us consider a linear quantization. Consider a linear quantization. Okay. So for this, for a signal with amplitude ranges from minus V to plus V. So the amplitude range of linear quantization. So this is a sinusoidal signal or any continuous signal. For that it has a minimum value of minus V, maximum value of plus V. So I quantize it linearly. That means with equal interval, right? So what is the total amplitude? Total amplitude is given by total amplitude is equal to 2V, right? Minimum to maximum. Let us assume this is 0. Here to here V, here to here V. So total amplitude is 2V, right? So and we know in that I have to find SNR, I have to find the del squared value and the normalized signal power. So del squared, I find it now. So what is del? Del is a step size. We know that, right? So del means this range, the gap between or interval between the two level. So what is the total amplitude? So if I want to find a total level, how can we find? So sorry, if we want to find this del, how can we find? The total range is 2V. If I divide this by total number of levels, I can find the interval between these two. Yes or no? For example, this is 10, this is minus 10 means total is 20, right? If it is divided into 10 levels means I have to divide by 10, so I will find gap between these two is 2. In the same manner, total level is 2V. I have to find a number of levels. If I divide total range by number of levels L, I find a step. So del is equal to 2V by L. L is the number of quantization level. Number of quantization level. We know L is equal to 2 power n. So in terms of bits, so 2V divided by 2 power n. So this is what step size we found, right? Now we substitute these values in the SNR value. So SNR is given by, what do you call? SNR is equal to, what is the numerator? Numerator is normalized signal power. Let me consider that is P. Denominator is del squared by 12. So del squared is this one, 2V divided by 2 power n. 2V divided by 2 power n. Del squared by 12, it is 1 by 12. Right? So if I simplify, what I get is, if you simplify, I get P divided by 2V squared by 2 power 2n, right? It is 4V squared, right? So 2V is nothing but 4V squared into 1 by 12, right? So if you simplify, what you get is SNR is equal to 3P divided by V square into 2 power 2n. This is what SNR value, right? 3P divided by V square into 2 power 2n, right? Suppose if you assume V is equal to 1, V max is equal to 1, right? What will happen? SNR will become 3 into 2 power 2n. Sorry, not V max. Here, sorry, if you assume V is equal to 1, not V max, V is equal to 1, it will become V is equal to 1 means T 3 into 2 power 2n into P. Fine. So, for example, if power is normalized to 1, if P is equal to 1 also, what will happen? Assume V is 1, P is equal to 1. This implies this will be equal to 3 into 2 power 2n. Now, this in terms of dB, I can write as SNR dB. SNR dB is equal to 10 log 3 into 2 power 2n, that is equal to 4.8 plus 6n dB. Right? So this is what, so SNR should be always lesser than this, not greater than this, so we have to make it. So SNR for PCM is given by SNR dB is less than or equal to 4.8 plus 6n. This is the thing we have to understand. Right? Now let us solve the problem. Right. The question is the input to a signal to a PCM varies in amplitude from minus 3.8 to plus 3.8. So they have given V value. V is 3.8. Right. Total interval is 7.6. Okay. Next, the average power they have given, that is 30 milliwatts. 30 into 10 power minus. Required SQNR also they have given. So SNR is 20 dB. Find the number of bits. What they ask is n value. Right? So what is the formula? SNR is given by SNR, that is equal to 3 into P divided by V squared max into 2 into 2 power n. Right? 2 power 2n. So SNR they are given 20 dB. Fine. So SNR in dB we have to know. So 20 dB is in dB. I have to write it in number, linear scale. 20 dB is equal to 100. Yes or no? So 20 dB is equal to 100. Why? So if I want to convert into number 20 log in SNR. So I write this 20 log this one. So this will be equal to SNR in number is equal to, sorry, it is 10 log, not 20 log. The signal power 10 log. It is power, so it is a 10 log. So SNR is equal to log SNR is equal to 2. So this implies SNR is equal to 10 power to 100. Okay. So P is equal to 100. So 3 into, SNR they are given. SNR is 100 in linear scale. P is 30 milliwatts. So 30 into 10 power minus 3. V squared is 3.8 square into 2 power 2n. If you simplify, what you get is n is equal to 6.98. So that is approximately equal to 7 bits. So n is equal to 7 bits is the answer. Right? So I hope you understand this formula and problems. If you have any doubt, please ask me. I will clarify. Thank you.